Hello everybody and welcome to the next video for section 6.6 in the classes at LACCD for the ITV program. Sorry everyone, I thought we'd have gotten past that. So just want to go ahead and walk you through at least the first question, let you know how this works, and then I'll give you some general outlines about how to graph the solutions to inequalities, which are going to involve some shading when we do this, which is going to be a little different. Okay, so for the first one here, they want us to determine if 2 points, 0, 4, and then negative 5, 4, if they are solutions for the linear inequality. So what we're going to do is I'm just going to copy this into two columns here, and at the top of those two columns, I'm going to write the equation that we're given. So this is going to be negative x minus 3y is less than or equal to negative 4. Now, the way these are written, they're written in a kind of form that's similar to the standard form that we learned about in the previous video, and that you'll have a chance to learn more about this weekend in our lesson, as this is being taped the Thursday before a lesson in class, at least if you're taking it in the fall of 18. So the first point we're going to look at is point 0, 4. And the second point we're going to look at is going to be negative 5, 4. So with the point 0, 4, what we're saying here is we're going to let x equal 0 and then y equal 4. And then the next point we're going to say x is going to equal negative 5 and then y will equal 4. So what we're going to do now is we're going to plug these points into the inequality and see if the inequality is true with these values. So this is going to give you negative 0 minus 3 times 4. And we want to see if whatever we get here is going to be less than negative 4. Well, negative 0 is going to be 0. Negative 3 times 4, that's going to be negative 12. So what we want to know is negative 12 less than or equal to negative 4? Now, when you are comparing, negative numbers, it can be tricky to make that comparison. So let's think about this on a number line. Let's just kind of take a look at some example values. Let's say 0 is here. We would say, and probably rightly so, that 2 is less than 10. And the reason we say 2 is less than 10 is because on the number line, it's further to the left. So anything on the left is going to be less than anything on the right, because the further you go to the right, the greater the value is. So if we say 2 is less than 10, one reason we can say that is because 2 is to the left. So if we were to take the values of negative 12 and negative 4 may be about here, and then negative 12 is going to be over here somewhere. Notice I'm not drawing this to scale. I'm just trying to present this idea in a general sense. So if we have this, we take a look. Is negative 12 less than negative 4? Well, it is further to the left. And just like 2 is less than 10 because it's further to the left, negative 12 is less than negative 4 because it's further to the left. So this is going to be true. Therefore, we can say that the point 0, 4 is going to be a solution for this graph. Let's go and take a look at this point now, negative 5, 4. And we're going to go ahead and put these values in now. So we're going to have negative 5. And put, now be careful. I got to be careful with this one a little bit here, because negative 5 is the value of x. But there's a negative that's also associated with this formula here. So I have to account for this by putting this in parentheses. Now we want to see if this is less than negative 4. Minus a negative 5, or negative negative 5, that's going to give me 5. That's going to be minus 12. Is that going to be less than negative 4? So 5 minus 12, well, that's still going to be negative 7. And we want to know, is negative 7 less than negative 4? Well, going by the same principle we just discussed a moment ago, if, let's say, we put 0 here and we have negative 4 here, negative 7 should be here, and because negative 7 is to the left of negative 4, this is also going to be true. So both of these are, in fact, solutions for this inequality. Now, to kind of understand this from a bit of a different perspective, I need to teach you a few things because we're going to come back, we're going to look at this question in a little more detail. And we're going to ask, why does it work out this way? So, print some graph people to be able to look at this so we can properly graph this. But while I'm printing that paper, I'm going to show you how we can take this equation that's written in like a semi-standard form and then put this into a form that we can graph. So, what we're going to do with this here is I'm going to take the equation here, negative x minus 3y is less than or equal to negative 4. You know, guys, I'm looking at this, and this is one that's not going to be easily graphable. I'm going to scratch doing that for now, and I'll hopefully be able to come back to this point about why these 2 points work later. So, scratch that for the moment. All right, let's take a look at this work now. Here it says graph the inequality. X plus y is greater than or equal to 3. So what I'm going to do is I'm going to just start with this. X plus y is greater than or equal to 3. There are a couple ways you could do this. If you wanted to graph this with the x and y intercepts, as we learned about in section 6.3, that is one way of graphing it. However, I strongly recommend, and at least in this example it's a very nice way to do it, that we put this in slope-intercept form instead, and then use the y-intercept and the slope to graph this line. So we're going to look at both questions 2 and 3 separately and then do a little comparison for how we graph these. But the first thing I need to do is to put this in slope-intercept form. And when we're converting from a standard form to a slope-intercept form, always remember that we're going to need to move the x, as I talked about in the last section. So when I do that, I'm going to get y is greater than or equal to negative x plus 3. Remember that if I'm moving this x over to the other side, it's going to switch signs. Now that I have this done, what I can do is I can identify the slope as being equal to negative 1, which I'll write here as negative 1 over 1. And then the value of b, which is going to be my y-intercept, is going to be plus 3. And remember, the b is where I begin. So I'm going to start at the origin. I'm going to go up 3. And that's going to be my starting point established by the value of b, the y-intercept. Now that this is written in slope-intercept form. Now notice here when we write this out, we use the equal sign. In terms of defining what makes up the value of the slope in the y-intercept, it does not matter whether we have less than, greater than, less than or equal to, or greater than or equal to. It won't change the value of m. It won't change the value of b. It will change how we graph this in a significant way. And I'll talk about that in a little bit. All right, so now that I have a point where to begin, I want to talk about how we move. Remember, the number at the bottom is always going to tell us how much we go to the right before we go up and down. The number at the top tells us how much we go up if the slope is positive, or how much we go down if the slope is negative. So in this case, since we have a negative slope, we're going to go to the right one, but then down one. Right one, down one. Right one, down one. And at this point, we should have enough lines to be able to draw the graph of this. Now, there's something I need to talk about before I draw this line. In the case when we're dealing with an inequality that has a less than or equal to or greater than or equal to, you're going to graph a line that is going to be completely solid. Nothing unusual to that. It's just like you learned before. However, if you are working with an inequality where it simply has it as being less than only or greater than only, you're going to end up putting a dotted line on your graph because we don't include any values on that line as being a solution for the inequality. So at least for this example, because this is greater than or equal to, we're going to go ahead and draw a solid line here. And I'll do the best I can with this. Yeah. Not perfect, but not too bad. There's my solid line. Now, there's one other feature we need to account when we graph the solution to this. That we want all values that are greater than or equal to this. So there's a rule that I need to introduce, And I'm going to write it in the following way. So I'm going to create a little extra space here to write that rule and bring this work up a little bit, making sure you can still see the work here. So here's the rule. The letter falls where it's less than. Okay? The letter falls where it's less than. So what happens is that on one side of the line we have on the graph, one side is going to represent all the points that are a solution for this inequality if we have a less than symbol for the inequality. And if you want to think of the pen as a ladder, the ladder falls where it's less than. So if this were a ladder, you just kind of let it drop suddenly. The ladder would fall this way. So this would constitute the less than side. If this side of the line is the less than side, then by default, this side of the line is going to be the greater than side. So I go back to my inequality now and I see what symbol is being used. Since I have here that y is greater than or equal to, what I'm going to do now is I'm going to pick points, or I'm going to pick this side of the line and I'm going to shade this side of the line, as I'm showing here. Now, why would I shade this side of the line? The reason I'm doing so is, what that tells me is that any point I pick over here, input into this system, is going to make this system true. On the other hand, if I take a point from the opposite side of the line, it's going to make this system false. All right, so let's just illustrate that with an example here. Okay, and for this, because I want to kind of show everything together, I'm going to focus out a little bit so I can show that work in a little more detail. So what I'm going to do, I'm going to write down the original equation, or the original inequality. X plus y is greater than or equal to 3. X plus y is greater than or equal to 3. So I'm going to start with a point on the greater than side. Okay, I'm going to start with a point on the greater than side. So let's see, one point could be, for example, let's say 6, 1. So I'm going to pick the point 6, 1, and I'm going to go ahead and put those values in. So 6, 1 is a point on the greater than side. If I take 6, 1 in, that means x is 6, y is 1. If I take 6 plus 1, that's 7, and 7 is greater than 3, this works out. That means that that point on that side is a solution. In fact, any point you pick over here is going to work out to be a solution to this. Let's just pick another example. Let's pick something you maybe wouldn't think would work. Let's go ahead and go to a point over here. So I'm going to pick the point -2, +8. So here's -2, +8. And I'm going to pick that point and put that in now. So if I do that, that's going to mean that -2 plus 8 should be greater than or equal to 3. -2 plus 8 will be 6. And yes, sure enough, 6 is going to be greater than 3. So that point works now. So again, further proof that any point on this side of the line should be a solution for this inequality. Let's show this with a counter example with a point on this side of the line. So here I have x plus y equals 3. So we can start with a point, let's just say 1, 1 for example. Just barely over the line, but everything's positive here. Okay? So since it's on the opposite side of the line, it should not make this inequality true. So let's go with the point 1, 1. So if I do that, x equals 1, y equals 1. Well, 1 plus 1 is 2, and 2 is not greater than 3, 2 is not equal to 3. This point does not work. Now let's go and do something else. Let's actually pick a point on the line. So here we had values that were greater, here we had values on the less than side of the equation, but here we're going to have values on the line. And I'm going to pick the point 2, 1. That's right on the line. So here's the point 2, 1. I'm going to sub it into this now. And that's going to read 2 plus 1 is greater than or equal to 3. So let's see, 2 plus 1, that's going to be 3. Now 3 is not greater than 3, but 3 is equal to 3. So you notice on the line, as long as 3 can equal 3, we're good. So this is how the principle of solving inequalities works. Now when you solve inequalities, notice there are a lot of values that could be true for this. So this is how we write these, this is how we graph these, and we shade this side to show all the collection of points that are going to make the inequality true. Now we're going to go ahead and take a look now at sample 3, or example 3 for the homework. And take a look at this in some detail. It says graph the following inequality, and it gives us negative 5x plus 3y is greater than 15. So the first thing I got to do is I have an inequality written in standard form. I'm going to write that in slope-intercept form. So remember, whenever you're going from standard form to slope-intercept form, we always want to make sure to move the x. So in order to do that, let me go ahead and box this. So I'm going to write this as 3y is greater than 5x plus 15. Now, when I have a number next to the y, to put this in slope-intercept form, I have to divide everything by 3. I divide this by 3. I divide this by 3. I divide this by 3. And that's going to give me now y is greater than 5 over 3x plus 5. Notice here that I write the x to the side, and the reason I do that is I want to be able to clearly identify what the slope of this equation is. And from here, I can say that my b value is equal to 5, and then my slope is equal to 5 over 3. And since we're looking at slope, we're going to say that we're going to move 3 to the right, and then we're going to move up 5 from that y-intercept. Okay, so I'll start with b. I'm going to put this on 5 here. The slope is going to tell me to go to the 3 to the right, up 5. Now notice here we can only get 2 points on here. If you want to try plotting 1 or 2 points backwards to help you graph a better line, you need to work backwards, and by that I mean go to the left, down 3. Repeat that. Go to the left. Go to the left, down 5 is what I meant. Sorry. Go to the left 3, go down 5. 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 And now you can see all these points will fall in a straight line. Now, before you plot this, when you're plotting an inequality, since it's only greater than, you have to recall what we talked about up here, where we said that for greater than or less than only, we're going to dot this line. And I'll explain the reason for this in a little bit. So that's going to be a dotted line there. So the last thing we have to consider is what side of the line do we shade? So in this problem here, since we have greater than, we want to take a look. What side of the line do we consider to be the less than side? If you were to think of this as the ladder, where does the ladder fall? It falls on the less than side. If this is the less than side, this is the greater than side. And since we have y is greater than 5/3 x plus 5, I'm going to shade this side of the line. And this is where all my solutions are going to be. So what I'm going to do to show this again one more time, and I'm not going to show this much afterwards, but I am going to just show this for this next example. We're going to pick 1 point on the greater than side. We're going to pick 1 point on the less than side, and then we're going to pick a point on the line. So for this one, try to leave this up here, and let's see here. So I'm going to look at this 3 different ways. I'm going to pick a point on the greater than side, pick a point on the less than side, and then 1 point on the line. And I'm going to go ahead and use the original equation here. So I'm going to have negative 5x plus 3y is greater than 15. I'm going to write that out 3 times. And 1 point I'll go ahead and just pick on this side. I'll try to keep something simple here. I'll just go with 6, 0. Okay, that's going to be an easy point to work with. So I'll pick the point, or sorry, not 6, 0, 0, 6. So be careful. Just make sure you pick the right points. 6, 0 would be over here, and that would not work. So that point's going to be 0, 6. A point on this side, even a simple one, let's just go ahead and pick 0, 0. See if that works or not. And I'm going to pick a point right on the line. Probably an easy one to see is going to be this point 0, 5, which is, in this case, the x-intercept, or the y-intercept, excuse me, 0, 5. And we're going to put these through, and let's see what happens in each of these cases. So we're saying that the solutions on the greater than side, this point should work. Let's see. So we have negative 5 times 0 plus 3 times 6. That should be greater than 15. Well, that's going to be 0 plus 18 is greater than or equal to 15. Well, is 18 greater than or equal to 15? It's greater than, so this side does in fact work. So we can check that by looking for a point on this side and make sure that we shade the correct side. Next, let's go ahead and check this point. Let's check the origin. This is on the less than side. This should not work if we've done our math correctly. So we have here negative 5 times 0 plus 3 times 0. So here we have 0 plus 0. And we're saying, is 0 greater than 15? No. This one works, but this one does not work. This one's not true. So fair to say we've probably come up with a pretty good graph of this. But let's take a look at a point on the line. Now, in the last problem, when we did it, we noticed that when we did that, the point came out to work. But let's see what happens in this case. So we're going to have negative 5 times 0 plus 3 times 5 should be greater than 15. So here we're going to have 0 plus 15 is greater than 15. So here we have, is 15 greater than 15? No. It's equal, but it's not greater than. So this doesn't work here. So what we're saying here is if you have a dotted line, the reason we dot it is because the line defines the border, but points that are on this line are not solutions to the inequality. In the previous example, we draw a solid line because points on it are solutions for the inequality. But on this one, solutions are not. So those are the two questions that are going to drive that point home in detail. We're going to take a look at other questions with some greater rapidity and take a look at what this looks like. Okay, graph the inequality. Y equals x plus 4. How very nice of them to give us an inequality that we can actually kind of pick things out quickly. So because this is written in slope-intercept form, I think I said it right, but it's y is greater than or equal to x plus 4. In this case, b is equal to 4, and then m is equal to 1, and I'll write that over 1. So I'm going to go ahead and put a line dot here at 4. This is going to tell me to go to the right one and up 1 because the slope is positive. Right one, up 1, right one, up 1. And you put a lot more points than that, but in the interest of time, I think you get the point. Hopefully the line too. And we now have the graph of this. Because it says it's greater than or equal to, I can keep that solid. So where's the letter fall? Less than. Therefore, this is the greater than side. And because we want to shade the greater than side, this is going to be the solution for our line right there. I'm sorry, that's a stray mark. I should not have done that. I am in the wrong. Please ignore that. Let's take a look at the next problem. It says graph the inequality y is less than 10. All right, so if you want to know the line y is less than 10, we have the cross. So what axis are, so we don't have an x-axis, or don't have an x value in this inequality. So you got to try to keep track of whether this is a vertical or horizontal line. What axis is it cross? Where does it cross? Those are the two questions you ask. It crosses the y-axis. It crosses at 10. Does it cross here? Now, because this is only less than, it's going to be a horizontal line, but it's going to be a horizontal dotted line going through the y-axis at positive 10, like so. Now, in the case of a horizontal line, if you drop the ladder, obviously this is going to fall down. That's going to be the less than side. This is going to be the greater than side. Because this is less than, this is where our solution is going to be. All right? So that's how we shade this here. The only time this becomes difficult for determining shading is with a vertical line. Not that it's difficult, but you just got to remember how it works. And alas, this is what we are coming to next. So the next equation we're being given, or inequality I should say, is x is greater than or equal to negative 5. So again, there's no y here, so hopefully you'll remember to ask the two questions. What axis does it cross? Where does it cross? It crosses the x-axis at negative 5. So I'm going to go ahead and put a point there. And before I draw my line, I need to ask, am I going to make it dotted or shaded? And because it's greater than or equal to, I can go ahead and put a solid line. Now, if you drop a ladder in this position, it most likely will fall. It's hard to hold it straight up in such a way that it won't fall. And it may fall to either side. So if you're trying to determine what side to shade, let the arrow do the work for you. See how this is pointing to the right? You're going to see shade the side of the line that this is pointing toward because they want values greater than negative 5. So what are those values greater than negative 5? Negative 4, 0, 2, 4. So this will do the pointing for you. So this is going to be the less than side. This is going to be the greater than side. Notice how this points this way and this points out. This is going to be the side of the line that you want to shade. And that's how you're going to do that one. Okay, let's take a look now at number 7. It says graph the following inequality. Okay, be careful of this one because you have things flipped around. So we have x is less than 2y. Now, there's going to be something I'm going to show you that you saw in the original video that will be very helpful to think about here. So I showed in my first video that 1 is less than 8. If I completely turn this around, I could then say that 8 is greater than 1. So what I'm going to propose doing here, since I want the y on the left and the x on the right, I'm going to propose taking this original statement and just flipping it around. So I can write this now as 2y is greater than x. Just like I did here. Here it's easy to see why I turn the inequality around. Here, not so easy. Another thing to consider, that the inequality is pointing at the x, it should remain so after you flip it. Once I'm done with that, I just divide both sides by 2, and I get y equals 1/2 x. One thing to remember about this, it doesn't explicitly give a y-intercept. But if you don't see one there, you could say that that y-intercept is going to be 0, which means that its y-intercept is right through the origin. Its slope is 1/2, and it's positive 1/2. So that means to plot points, I'm going to go to the right 2, and I'm going to go up 1. And let's see. Oh, and by the way, guys, I should probably put this as a greater than sign. I forgot I put that as an equal. I apologize. So that's going to be greater than symbol. And because it's only greater than, when I plot my line, I'm going to dot it. Okay, so now I want to determine what side is the greater than side. If this is my ladder, this is less than because this is where the ladder falls. This is my greater than side. This is the side I want to shade. And there's going to be my solution. Let's check out number 8. Yeah, and by the way, at this point, hopefully, you should be kind of working on stopping the videos. Try some of these questions yourself. If you want to stop the video with this time to rewrite this problem as something that you could work on graphing. But be careful of this one. This one's tricky. All right, if you stop the video and try this, all good luck, because this one's going to be a tricky one. If you're just listening, let's go forward with this. So if x minus y is less than or equal to 9. So this is written in standard form. So I'm going to just go ahead and move the x to the other side, giving me negative y. Keep the negative with the y. Don't forget that. Is going to be less or equal to negative x plus 9. Here we have a negative y. I need that to be positive y. So I need to divide by negative 1, negative 1, negative 1. This will get me y. This will give me 1x. I'm just writing the 1 here, kind of the whole of the value. This will give me a negative 9. However, because I'm dividing by a negative number, I need to switch the direction of the inequality. So this will now read y is greater than or equal to 1x minus 9, meaning that the b value will equal negative 9, and then the value of the slope is going to equal 1 over 1. So when I'm plotting my point here, I'm going to start here, and then I go to the right one up 1, the right one up 1, the right one up 1, the right one up 1. You get the idea. And because it's greater than or equal to, I can go ahead and make this into a solid line. Now I have to determine what side do I shade. If that's my ladder, I'm going to fall this way. That means the other side is the greater than side, and it's the greater than side that I want to shade. So there's going to be our solution set right there. Okay? All right, next question. Going to be number 9. Again, you may want to pause the video on this one. Just bear in mind, you're going to need to convert this from standard form to slope-intercept form. All right, so if you didn't pause the video, here we go. So we're going to have 5x minus 5y is greater than 10. Hopefully, if you try this on your own, you didn't fall into the same trap you may have fallen into the first question. I'll write this now as negative 5y equals negative 5x, because I moved it over, plus 10. Now if I divide by negative 5, divide by negative 5, divide by negative 5, whoops, and by the way, I should make that not